current in conductors. In atoms and molecules, the negatively charged electrons and positively charged nuclei are bound to each other and are thus not free to move. But these molecules are so closely packed that the electrons are no longer attached to individual nuclei. In some materials, electrons will not accelerate even if external electric field is applied, are called insulators. In other materials, some of the electrons are practically free to move within the material. These materials develop an electric current in them when an electric field is applied, are generally called conductors. Tap the key to see the effect. In solid conductors, atoms and nuclei are tightly bound to each other. Therefore, the current is carried by the negatively charged electrons. However, in conductors like electrolytic solution, both positive and negative charge can move and causes current. Now we will talk about solid conductors only. In solid conductors, when no electric field is applied, electrons are moving due to the thermal motion and collide with the fixed positive ions. After collision, speed of the electrons remains same, but direction is arbitrary. At a given time, there is no preferential direction of velocity. Therefore, on average, the number of electrons traveling in all the direction is same, so there will be no net current. Let us consider a conductor in shape of cylinder having radius r. Now, an electric field is applied across the two ends of the piece of conductor. We now take two charged discs of same radius and put positive charge plus q distributed on one disc and negative charge minus q on the other. We attach the two discs on the two flat surfaces or the cylinder. An electric field will be created and is directed from the positive towards the negative charge. The electrons will be accelerated due to this field towards plus q. They will thus move to neutralize the charges. The electrons, as long as they are moving, will constitute an electric current. Hence, in the situation considered, there will be a current for a very short while and no current thereafter. Now we can imagine a mechanism where the ends of the cylinder are supplied with fresh charge to make up for any charge neutralized by electrons moving inside the conductor. In this case, there will be a steady electric field in the body of conductor. This will result in a continuous current in the conductor.